This video is going to cover the basics of inequalities, how to use the symbols and how to draw them in a number line. The second video will show you how to use algebra and to solve inequalities. Okay, there are 4 symbols you need to know, which look a little bit like crocodile mouths. This one, symbol pointing the other way. This one, which is quite similar to the one at the top. And then, you probably guessed this one. Okay, and these have meanings. The first one means that whatever is on this side is bigger than whatever is on this side. So this means greater than. If you can read my writing. The second one, well, this one means that this side is bigger than this side. Okay, so that is, we would read that as less than. Okay, it's be a little bit clearer whenever I start putting some numbers in. And the 2 at the bottom, the same thing, greater than and less than, but this time we've got this second line. So this one means greater than, if I could spell greater, but equal to, or equal to, sorry. And then the one at the bottom reads as less than, or equal to. As you see the bottom of them in both, this looks like an equal sign, so it's the equal to. Okay, let's stick some numbers in, it might make a bit more sense. Okay, let's look at how we put these symbols into these. Okay, we've got 5 and 2. Okay, 5 is more than 2, so we would use the inequality 5 is greater than 2. Okay, the crocodile mouth, this bit, as I like to call it, always goes towards the bigger of the 2 numbers or letters on each side, because you could be using this with algebra. So 5 is greater than 2. Okay, let's look at the one at the bottom. In this one, you've got 7 and 23. Well, 7 is less than 23. Okay, so I need the crocodile mouth to be pointing towards the bigger, to be at the bigger number. So this reads 7 is less than 23. Okay, right. Let's put some questions up and you practice some. Okay, have a go at these questions and I'll put my answers up in a second, so press pause in the video. Okay, there's the answers. Remember, the opened end of the crocodile mouth always is beside, as open as if it's going to eat the bigger number. Okay, let's look at some other things we can do with these. Now, another important use of inequalities is using them on a number line. Okay, and I've drawn some. So these diagrams represent some inequalities. This first one, the top one, we can see that there's a little circle above the number 1. And it's an empty circle, and the arrow points to the right. Okay, so this shows me that all the numbers that would make it true are greater than 1. So I could have 2, I could have 3, I could have 4, I could have 5, 6, 7, 8, 9, 10, and so on. Okay, so this would be written as greater than, or x, whatever the number is greater than 1. In the second question, the little circle is above minus 1. Okay, so this is going to be minus 1. And all the answers, the solutions to this, are on this side of it. So minus 2, minus 3, minus 4, minus 5, minus 6, and so on. So what values would work in this? Well, minus 4 would work, minus 3 would work. So x, the numbers that would work, have to be less than minus 1. So it's described like that. In the third one, again, the dot is above minus 1, but this time it's shaded in. If it's shaded in, that means the answer to this inequality could be that number that it's above. So this time we're going to be using a less than or equal to. So this time, all of our answers, we could have 0, 1, 2, 3, 4, 5, so on. So our numbers have to be more than minus 1, or equal to it. So x, the numbers that we could be, are greater than or equal to minus 1. In the fourth one, this time our circle is above 2 and it's coloured in, so that means it's going to be an equal to inequality. So this time all the numbers are going to be smaller than the number 2, all the way down to minus 4 and so on, carrying on. So this time we're going to have a less than or equal to. So the numbers that would work, x is less than or equal to 2. Okay, so if I put the number minus 3 in there, that would still be true. In the third question here, if I put in the number 0, 0 is more than or equal to minus 1. I could also be minus 1. Okay, so if we're representing inequalities in a number line, if it's less than or greater than, it's an empty circle. If it's equal to, so if it's greater than or equal to, or less than or equal to, it's got to be a shaded in circle. Right, let's try a couple of questions then on this and see if you can write the inequalities for these. Okay, here we go. There's 9 questions. See if you can write down the 9 inequalities that these number lines represent. Okay, in question 1, the dot is above minus 2 and it's shaded in, so it's going to be a greater than or equal to or less than or equal to. So all the numbers that the arrow is pointing towards are more than it. So the answer to that would be any number, x, which is greater than or equal to minus 2. In question 2, the circle isn't shaded in. Okay, so in question 2, what have we got? So the numbers that would work there would have to be less than 1. Okay, so I need less than 1. Remember, it's not equal to because it's an empty circle. Question 3, we've got empty circle, so we want numbers that are on this side of it, so they're all greater than minus 4. So numbers that work in there, x, have to be greater than minus 4. Right, question 4, I'll go through these a bit quicker. That is x is less than or equal to 0. Question 5, empty circle, and it's x is greater than 2. Question 6, x is less than or equal to minus 1. In question 7, x has to be less than or equal to 3. Question 8, we've got empty circle, and we want numbers that are greater than minus 2. So x is greater than minus 2. Last one, number 9, filled in circle. What values work there? Anything that is greater than or equal to 1. Okay, let's try a few. Okay, have a go at drawing those 4 questions there, please, on a number line. I'll give you the answer. Okay, so in the first one, x has to be greater than or equal to 3. So it's greater than or equal to 3. So circle above the 3, but this one needs to be shaded in. And our answer has to be bigger than 3. So it can't be 2, because that's smaller. It could be 4, it could be 5, it could be 6. So it's any number that way. Second one, x is greater than minus 6. Okay, it's not equal to, so I need an empty circle above minus 6. Now, what numbers work? Okay, so try a number. Is minus 5 more than minus 6? Yes. Is minus 7 more than minus 6? No, that's smaller. So we need the arrow pointing that way. Question 11. Y is greater than or equal to 2. So I need a circle above 2, but it's equal to, so I need to shade it in. Okay, not easy to shade it in this. And y has to be more than or equal to 2. So what numbers would work? Well, 1 wouldn't, because that's less than 2. So I need 3, 4, and so on. I need it pointing that way. And the last one, D has to be less than 5. So where's 5? There's 5. Put a circle above it. No, it's not equal to it, so I leave it empty. D has to be less than 5. So if I put 6 in place of D, that wouldn't be right. 6 is not less than 5. So my arrow must be going that way. I probably could have done with being a bit straighter. Okay, you may get a question like one of these. We have to draw a number line, and then it's part B I want to talk quickly about. It's got this special word in it called integers. An integer is just a whole number, positive or negative. Okay, and it'll be a bit more obvious once we do this first question. Okay, so if I do question 1. So in question 1, we know that x has to be greater than or equal to 1, but it has to be less than or equal to 4. So we need to draw that in a number line. So we need to draw a quick number line. Right, it needs to go between 1 and 4. Now, x has got to be greater than or equal to, okay, so that circle needs to be shaded in. It's got to be greater than or equal to 1. So I've got 2 in there, and I've got 3 in there. It's not a very good number line. So, okay, so x has to be on this side of that line, because it's got to be bigger than 1. But x, we're also told that x has to be less than or equal to, so shade in the circle. If I could shade it in. But it has to be less than, so it has to be that side of 4. So you join the two lines up. So that is part A done. Part B says write the integers that satisfy each of the inequalities. Now there's an infinite amount of numbers between 1 and 4 if you think of all the decimal numbers there could be. So what are the integers, the whole numbers? Well, remember, this is equal to. So our answer for part B would be 1, 2, 3, and 4. Okay, be careful if it's equal to, or if it's just less than or greater than. Alright? Okay. Have a go at question, well, have a go at the rest of those questions. I'll give you the answers to 2, 3, 4, 5, 6, and 7, and the rest will be there for you to do. Okay, there's answers to question 2 and question 3. Notice in question 3 that the integer list of integers, 3 is not one of them because it's not equal to 3. Okay, x has to be more than 3, so the first whole number after 3 is 4. So 4, 5, 6, and 7, and we include 7 because it could be equal to, it's less than or equal to.